about magnetism. Action picks up a paperclip.
I think magnets are attracted to paper clips.
Magnets are attracted to nails, like that you hammer.
I think magnets are attracted to crayons.
I think magnets are attracted to staples.
I think magnets are attracted to pencils.
Are attracted to metal washers.
Magnets are attracted to plastic like this cup. Magnets are attracted to coins.
After interviewing and recording the answers of many elementary students, it's clear that they have a lot of different ideas about what magnets do and what they're attracted to. Most of them understand that magnets are attracted to metals, but oftentimes students think that all metals are attracted to magnets. Elementary children also often think that all coins are attracted to magnets. It is hard for children to grasp the concept that there are some metals that do not stick to magnets. In the previous work on this topic that I researched, the experiments did not include a poll of what metals children thought were attracted to magnets. My investigation includes this because I think it is important to ask children what they think about the topic. I got the idea for my experiment from a few different websites online. One experiment had a set list of metals to try. My experiment is open to whatever the children are curious about. Another experiment I saw while looking for ideas involved experimenting with different coins. The children experimented with quarters, dimes, nickels, and pennies to see which coins were attracted to the magnets. They then furthered the experiment by seeing what each of the coins was made out of. My investigation is slightly different than both of these, but still uses the same principles and comes to the same outcome, the knowledge of what objects are attracted to magnets. My research question will be, which of the objects will be attracted to the magnet? My hypothesis will be, I think some of the metal objects will be attracted to the magnet. The investigation that I will be conducting is experimental. The independent variable in my investigation is the different objects that the children told me they believed were attracted to magnets. The dependent variable is whether or not these items are attracted to the magnet. The controlled variable will be this magnet. I'll use the same magnet for the whole experiment. To conduct my experiment, I put each object up against the magnet. If the item did not stick to the magnet, I came over to my data sheet and checked no. If the item did stick to the magnet, I went on my data sheet and checked yes. I did this for each object. At the end of my experiment, this is what my data sheet looked like. During my investigation, this is what I found. The crayon, penny, quarter, dime, nickel, plastic cup, and pencil were all not attracted to the magnet. The metal washer, nail, staples, and paperclip were attracted to the magnet. During my research, I found that magnets attract to ferrous metals. These are metals such as iron, nickel, cobalt, and certain steels and other alloys. Brass, aluminum, copper, and most stainless steels are non-ferrous. This means that the yes objects are made of ferrous metals and the no objects are made of non-ferrous metals. During my investigation, I encountered one major difficulty. The film that I got while I was pulling the children to see what they thought would be attracted to the magnet got lost, so I had to use actors and actresses to act as the children for my film. For further research on this topic in the future, we could ask why these objects are attracted to the magnet. During my investigation, the biggest thing I learned was what metals were actually attracted to the magnets. I relearned what independent, dependent, and controlled variables are.
People talk about attraction, it's all about magnetism action. Picks up a paper clip, let me give you all a tip. Magnetism even plays a part with microchips to make your computer spin. That's where information begins. Magnets work in a vacuum.